Hi, welcome back. This video covers the explanation or the mathematical explanation of what potential energy is all about. Potential energy that we're talking over here is basically the gravitational potential energy. So let me just add it here. So gravitational potential energy. So gravitational potential energy. We have the spring potential energy, but we're talking about gravitational potential energy right here. So it means, so let's say this is the lowest part of the ground on the surface of the earth, or any surface that you might say. Let's say I have an object being raised at a certain height. So it is being raised at a certain height, h, or sometimes we call it delta y. Okay, so the change in position in terms of y. So if we're holding this object and we let go of it, possibility is that it will move. So it will move, it will go down because of gravity. And that amount of impact or work done or energy or the ability to move from the highest position to the lowest position is basically called the potential energy. Okay, so the potential energy, how much potential it will have. The higher the object is being raised, the greater the amount of potential energy. Why is it so? Because the equation of potential energy, or gravitational potential energy, also known as PE, is equivalent to the mass multiplied by the acceleration due to gravity, or also known as the gravitational field strength, and multiplying it by the height. So mg multiplied by height. Or in other texts, you might see something like this. Instead of using PE, you'll have U mass times g, and then instead of using h, you will be using the change in location along the y-axis. However, we will focus more on this equation, as this will be something that we will use in most of our problems. Okay? This one, even though it's another form, it's not something that we will use in this lesson, but instead we will be using the PE, mg, h. So what is basically potential energy? So potential energy is PE, and the units of energy, because based on the previous lessons that you've seen and watched, potential energy or energy is the ability to do work. So basically they have the same unit. So the unit of energy is basically the same as work, which is joule or joules. And the unit is in terms of J. Mass is the same thing. Mass is represented by letter m, lowercase m, not uppercase. The unit is kilograms. So kilogram or grams, so that is kg. Now acceleration due to gravity, which is letter g, is in terms of meter per second square. Okay, meter per second square. So meter per second square. And on the surface of the earth, the acceleration due to gravity is approximately 10 meter per second square. So this will be the value that we will be using. Instead of 9.8, we will be using 10 meter per second square, rounded off. Height, let me use a different color pen. Height is in terms of h, and that is in meter or meters, and the symbol for meter is lowercase m. So therefore the mass of, now something that you must remember, that when you multiply mass and g, so when you multiply this two value, is basically what we call the weight, and weight would have a symbol of Fg, because that's force of gravity. So that is basically your weight. So weight is also known as Fg, which is equivalent to the product of mass times g. So now when we're solving problems such as potential energy, I want to solve for the potential energy. The equation that we're going to use from our base equation or the formula is mass times g times height. Mass g times height. So, three variables that needs to be known when you are reading your problem, trying to discover what your problem is. We need to know the value of the mass. It's already given that g is always the same, which is 10 meter per second squared, depending if you are on the surface of the earth. And last but not least is you must know the value of your h. So you must know these three things in order for you to solve for PE. So that's basically what this table is telling us. And we've been using the same table in previous lessons or previous videos that we have. Now, in terms of mass, so we can solve for mass. So we can manipulate this equation. I could say that my mass is simply equivalent to the given potential energy. So if you're reading your problem trying to figure out what is given and what are you supposed to be solving for, always look for your potential energy. So potential energy divided by the acceleration due to gravity and the height. So any value we have on the right side should be in this middle row of our table. So therefore, if you're reading the problem, you must know the value of the potential energy in order to solve for mass. Of course, we should also know the value of acceleration due to gravity, and if it's on the surface of the earth, that's basically 10. And the last value we know is your h. So this time we have to divide your potential energy by the product of 10, which is acceleration due to gravity, multiplied by the height. So what I'm going to do next is to skip the height section and let's proceed with the weight section, and let's proceed with the height section first. So height, in order for us to solve for height using the original equation, height is basically our potential energy divided by the mass and the acceleration due to gravity, mg. Things that we should know, of course, we need to know the potential energy, which is on the right side of the equation, the value of acceleration due to gravity, which is 10 meter per second squared, and we should know the mass in terms of kilogram of the object. Okay? Kilogram of the object. Now, why did I skip about the weight? Because now we can go over weight. According to this section of today's notes, weight is basically Fg, which is also equivalent to mass times g. So it's either we're solving for mg or we're solving for Fg. So there's two ways on how to write the equation. It's either we are solving for Fg, which is the weight, which is simply equivalent to potential energy divided by the height, or we can say we're solving for mg, and that is potential energy divided by the height per se. So there's two things that we must know. We should know the value of potential energy and of course the height. Okay? Potential energy divided by the height, that is equivalent to your weight, or sometimes known as mg. Now, also in terms of height, what is mg? Okay, so now we can change this and add another equation, which is h can be solved using PE over f of g, which is also equivalent to your weight. However, what I want you to do is focus on this equation, the second equation, and the third equation. There might be some instances that they will ask you questions about weight, but here are the three equations that we focus on, which is how do we solve for potential energy, how do we solve for the mass, and how do we solve for the height of an object. See you in the next video for some word problem example on potential energy.